Okay, we're going to start looking at composite functions. So that's section 10.3 of the textbook. Now there is a common mistake that people make. So we're going to look at composite versus multiplication of functions. And this more has to do with how it actually looks when we read it. So if we have here, this is f times g of x is equal to h of x. And so that's going to say that's a function multiplication. So that means we're multiplying f times g, which we've already done. Now the very little difference though is if you look at this compared to over here, we've got an open dot here. This does not mean multiplication. This means it's a composite function, and we would actually write this as f and then in brackets g of x. Now that kind of looks weird right now, but if we go to our first question, we have given the functions f of x is equal to x squared minus 3 and g of x is equal to 2x, evaluate each of the functions. So we have m of 3 is equal to f and then the composite g of 3. And we want to put these in, figure out what this is actually equal to. Now we've already kind of looked at last time. This is the same as saying this. So we have g of 3, which doesn't really seem any simpler than this. But the first thing we need to do is actually figure out, well, what is g of 3? So we go and find what g of x is. So g of 3. And we're going to substitute in 3 for x. So 2 times 3 is 6. Now we can replace this g of 3. We know that's equal to 6. So now I want m of 3, which means I'm going to take my f of, well, 6. Because that's what g of 3 was. It was equal to 6. So now if we go look at the f of x function, we have x squared minus 3. So we're going to replace the x values with 6. So it's going to become 6 squared minus 3. So 6 squared is 36 minus 3. So we get 33. So m of 3 is equal to 33. Let's take a look at our second question. So n of 1 is equal to g of f of 1. So again, we've got a composite function. So I'm going to figure out what f of 1 is first. So f of 1, so that 1's going to replace our x values here in f of x. So it's going to be 1 squared minus 3. Well, 1 squared is 1, minus 3 is negative 2. So now I actually want g of negative 2. And the reason is we've already figured out what f of 1 is. So we're going to replace everything inside this g function with this negative 2. And that negative 2 came from that f of 1. Okay, so our g of x is equal to 2x. So now it's going to be 2 times negative 2 because the x is replaced by negative 2. And we get negative 4 as our n of 1. Our last question. So here we have p of x is equal to f of x. So a couple of little differences. So we're using the same function twice inside the composite function. And also, we're not actually told what we wanted x to be turned into. Like we don't have a constant in there. And that's okay. I'm going to rewrite it a little bit differently this time. So we've got p of x is equal to f, and then inside of that, of f of x. Now, f of x, well, we replace everything in x with x, so it actually stays the same. So that I'm left with this is equal to x squared minus 3. And then now I want to do the same thing. So I'm going to place this value, whatever this is in here, I'm going to place it inside the x variable. So now this time we have a binomial. And our x squared is going to get replaced with that. So it's going to become x squared minus 3. And then that's all squared. So that's our x squared term. And that's still minus 3. Now we can start simplifying this. So I'm going to do FOIL. So I get x to the power of 4. And then minus 3x squared minus 3x squared plus 9 minus 3. And then we'll combine like terms. So we have x to the power of 4. And then we have minus 6x squared. And we have plus 6. So this is what p of x is equal to.